earthly behavior, earthly behavior, earthly behavior. Good afternoon, ladies and gentlemen. This is Dr. Walt with Earthly Behaviors for MCTV. We're going to talk about a subject tonight that's very unusual. You all know about climate change, but you may not realize that there may be ways to reverse it, to stop it or halt it some way. Now, clearly, this raises some moral and ethical questions we'll have to deal with. And clearly, we don't have the political will to make these changes right now. Certainly not in the United States, but not in the world in general. We have the Copenhagen treaty talks recently failed, and so we still have yet to find a global urgency to stop or reverse climate change. In the meantime, we are saying, we being the scientists of the world, are generating ideas for the consideration of the political leaders. Whether they take us up on it or not is another thing. We think that this rapid climate change raises the stakes on it. This is not just your ordinary problem, it's a global problem, and we all contribute to it. We want that any plan that we have or any trick we come up with has to be reversible, and that's because there's often unintended consequences for these kind of things. The approach must work quickly to be practical, and quickly in this case is on the order of 5 years, 10 years, 15 years. Of course, we would love to have the political will of the situation in hand. Can I have the next slide, please? The current situation will cover that. I'll point out that there's active and passive approaches to this kind of thing. We'll talk about geoengineering, which is applicable to any planet, as versus terraforming, which is applicable to the Earth itself. We'll be wary of unintended consequences, certainly, and we'll consider the ethical problems, and then summarize it all at the end. The reality is the planet is reliably heating. There's simply no doubt about it. If anyone looks into the evidence, don't believe me, don't believe the scientists, just look into the measurements, you'll see the planet is warming terrifically fast, much faster than has happened in the last 400,000 years. And that during that period, there were several ice ages. So we suggest that the signs for this thing are well aware. I mean, we're obvious. The ice caps are shrinking. There's increasing droughts. There's increasing severity of storms. The migration patterns of birds are changing. The amount of time you have spring planting or when winter comes, that's all changing all over the Earth. There was a recent national science advisory given to the world, especially to the presidency and the political parties involved. This is serious. It needs to be dealt with. It's very hard to get a politician's attention. We also have to be careful of tipping points. We don't understand the Earth so well that we can predict ahead if you go past this point, say, in the size of the ice caps or the swelling of the oceans, that we'll never be able to go back again. That's a tipping point. Irreversible changes. We, of course, want to avoid that. This slide presents some of the ways that we're using these scientific ideas to invent ways to reduce the heating in the planet. Here you have giant reflectors in orbit that would reduce the solar incidence just by 1 or 2%. That's enough to compensate for the heating that's happening because of carbon dioxide. Another approach is to not use a solar shield in orbit, but to use particulate matter in the stratosphere placed there by aircraft. It would slowly settle out over a period of years and would have to be renewed, but it also would act as a solar shield. We have cloud seeding. That's certain clouds will respond to particulate matter in them, specifically silver iodide, and it will make the cloud rain about 40% of the time. That's one little trick that is being used by governments nowadays, including the Israelis and the Russians and the United States as well. Of course, getting the carbon dioxide out of the atmosphere is the real trick. That's the greatest heat-trapping gas that we have. Unfortunately, it's tied to the economies of the world because fossil fuels run a lot of the industry. And if it was another kind of gas that was not so tied to economies, it would be much easier to regulate. So far, the regulation is poor. But there are schemes, and I will show you some of them today, that pull the carbon dioxide out of the air. What to do with it when it's out, and we have it liquefied. There's two schemes afoot. One of them is to inject it into the deep ocean, and the other one is to inject it into deep rocks. We won't talk about which one of these is best. The consequences will become clear. And a final scheme that's around is to seed the ocean with soluble iron, making it bloom algae and suck CO2 out of the air to form their bodies. And then ideally, they would die because the iron sulfate the soluble iron is finite. We can't keep putting it in forever. And so those algae would then die and sink to the bottom of the ocean, what would pull the carbon dioxide out of the atmosphere. So these are the kind of ideas, big-time ideas, planetary level thinking that we're going to talk about today. The recent conference at Asilomar, which is right near Palo Alto, it's a famous place because they made up the bioethical questions for genetic engineering and stem cells. So these folks came together a few months ago. They're all high-level scientists. And this was some of their conclusions. They said any project that we do globally, whether it's sun shields or whatever, pumping CO2 into the rocks, has to be ethical, done with humility. We have to be very careful of unintended consequences. They recommended as the first option blocking the sun's rays in some way or another. It was the easiest thing to do, quickest, cheapest, and most effective. It also could be varied later on. The second thing was to actively remove carbon from the atmosphere. There are ways of doing this. If any of you read about submarines, you know that people stay underwater for weeks or months at a time, and so the carbon dioxide they breathe has to be removed from the atmosphere of the submarine. There's established technologies that do this. What we're proposing here is to do it for the planet. Then the third thing they suggested was the genetic engineering of crops. They see ways that plants, especially corn and rice, could be made much lighter colored. That would reflect more radiation from the sun off of the planet, and it would take away some of the reason for warming. But the conclusion from the whole conference was first to set up ethical guidelines so that this could be handled properly. The current situation is the planet is definitely warming. There's no doubt about it. There's fear of tipping points. For example, we're losing the ice caps of this planet. It's not a necessary thing for a planet to have an ice cap. There's several others, and we've had them as long as we've been self-aware. But there's also ways to lose them. And when you look at an ice cap melting, let's take the northern ice cap, for example, you can see it's very reflective of sunlight. It's not quite a mirror, but it's up there about 90% reflectance. Well, when you take away that ice, what's underneath it is the ocean. And the ocean is very dark, so it will absorb a lot of solar radiation. So once you take that ice away, it's very hard to get it to grow back. And if we lose the ice cap, which we probably will in the next 40 years, in the summer, and just the northern ice cap so far, we'll find it very difficult to recreate it. So the basic question is, can we modify the planetary heat budget? The heat coming in, the heat going out. Can we modify that in some way so that the heat doesn't build up? Well, the first way that was suggested by this conference is blocking sunlight. There's several ways to do that. One of them is high-altitude aerosols. Here's an example. Aircraft, probably drones, would go up under the 70,000-foot category of altitude and spray ice or water or sulfate chemicals that would slowly settle out. Now, the stratosphere is a very quiet place. All the action in weather generally happens down below about 30,000 feet. And when you get above that, you find that it's very quiet. Things can stay in, particulate matter can stay in the stratosphere for months or years. We're not the only ones to put things in there. Volcanoes do it quite well. Mount Pinatubo, blowing up about 30 years ago, put about a cubic mile of pulverized rock into the air, into the stratosphere, and it created a planetary veil around the planet, quite measurable, and the total planetary temperature dropped about 0.6 of a degree. That's a lot of heat. We'd like to be able to do something like that without the volcano part. So that's the one option. It would require a fleet of drones. It would be reversible if necessary. Don't see any ecological consequences. This would be very fine film spread out over the whole planet. And we could stop it in time if it came to that. Another approach has been whitening the clouds with sea salt. This was recently tried off Scotland. They basically took a ship and sprayed seawater, high up into the air and found that it would change the reflectance of clouds about 8%. If they could do that for large areas, this would make a significant contribution to keeping the heat off the planet, that side of the heat budget. The third scheme is to have a space parasol or solar shield. Now, we could do this. It would take about 10 years to do it. It would cost about $15 billion, but it would be an object that would be in orbit. We could control it. We could make it larger or smaller as necessary, and it would block about 1% to 2% of the solar radiation. You would not be able to notice this very much in the sky as you looked up at it. You might see a small speck, but that would be about it. It would make a significant difference in the planetary heat budget. If there's other ideas around, we'd like to hear about them. The albedo is a term that we'd like to get you familiar with. It means about the same as reflectance. In other words, a mirror has a very high albedo, 100% reflectance, whereas dirt has a very low albedo and doesn't reflect very much and therefore absorbs much more heat. So there's a disproportionate effect on the albedo of losing the sea ice, which we've already spoken about. Ice is very reflective. When you take it away, you got a deep, heat-hungry ocean underneath it. It's been suggested that we could genetically engineer crops to make them all whiter. This would go for lawns as well as corn and rice, and it would depend what is the crop that has the most surface area. It's been suggested, too, artificially whitening ground surfaces. There's people who are perhaps a little deluded on Mount Kilimanjaro spreading white tarps along the ground to preserve the white snow on the cap. That's a little bit much. I personally have put a white tarp on the roof of my house. This was suggested by the head of the Department of Energy, Dr. Stephen Chu, who's a Nobel Prize-winning physicist and nobody's fool. He said we should paint every roof in the country white. It would be fine, easy to do, no maintenance, would reflect a lot more sunlight. We'd be a lot better off. In fact, it'd be patriotic to do that because we wouldn't be dependent on outside fossil fuels so much. Another scheme that has come about is to seed the ocean with materials that would make the algae bloom. That's the iron fertilizer business. In the science of lakes, which is limnology, they find that there is a chemical in every lake that limits the growth to the lake. Usually in lakes, it's phosphorus. Well, the same idea applied to the oceans, discovered by an Australian guy about 20 years ago, was that if you have soluble iron and you throw it in the ocean, you get an algae bloom out of that. This has been done. They get it. And they were ready to go further with it until wiser heads prevailed and said, let's study all the consequences of this. We don't know, for instance, whether the algae that's created and suck the CO2 out of the air to make their bodies, whether they'll all drop away. They may float to the top and decompose and put the CO2 right back in the air again. So while they're holding off, the free market system is working, and there's a company in California which is offering carbon credits. They say, well, we'll just, if you give us money, we'll sell you a carbon credit, it's a piece of paper, and we'll throw a bunch of iron, soluble iron in the ocean in your name. Questionable. So another way we have of looking at this is cloud seeding. Rainmaking is a long tradition, both not just in this country, but in Russia and Eastern Europe as well. Many rural areas, people go around as rainmakers, and what they do is they inject silver iodide into the air in one form or another, and if they pick the right cloud and at the right time for the cloud's development, the material adds extra surface area, and the rain can condense, the water can condense and fall out. The ethics of this is unclear. Some people say that it's stealing water from the folks downwind. Meteorologists would tend to say there's plenty of water around. You're not stealing it from anybody. 3/4 of the planet's surface is oceans, so we don't have to worry about stealing water from anybody. More rain, though, addresses the effects of climate change rather than the causes of climate change. The heating of the planet will change how the rainfall is brought to various areas of the world. And some droughts, mega droughts, are expected in some areas of the world that are rice bowls. The Chinese rice bowl, the Australian wheat bowl, and the American Midwest, of course. The Soviet Ukraine are expecting to have trouble finding the water to come down out of the sky. Their cloud seeding could work. But as far as affecting the heat budget of the planet, probably not. The other subject is genetically engineered crops. Now, this is not very popular for the food folks. They don't want any crops to be genetically engineered because the effects of them have not been fully known. But unfortunately, or fortunately, depending on how you look at it, there's a lot more food being produced because of these things, and we're probably unavoidably eating some of them now. The genetic engineering could be applied in numerous ways. You could make forests grow faster with whiter crown tops. You could change the color of crops. You could make crops that are not crops, but just non-crop plants, have them change color as well, change it into a whiter. All the genetic engineering seems to be opposed by environmental groups, so there would be a lot of political power to play on that one. More research is needed on this quickly. We don't know whether any of it is feasible yet. The most popular scheme so far out in the scientific community is that to actively purge CO2 out of the air. I'll show you an example of this in the next slide, but basically we know that the Chinese are putting a coal-fired power plant online every week. They've become the greatest importer of coal in the world. We know that the political will is not present in the globe to slow and reverse climate change. So the backup position is to invent something that sucks the air through it and purges the CO2 out of it and then puts the air back in the atmosphere. There are such things. The first way of doing that was the ocean algae we already talked about. Another way this happens on Earth is straight carbonate chemistry. It's happening all over. The rocks weather, and rocks absorb CO2 and release CO2, and the plants, of course, are doing their cycle. People have proposed a special nuclear facility. In other words, you make a nuclear plant, maybe out in the desert somewhere where it doesn't bother anybody, and you dedicate it just to sucking CO2 out of the air. This could be done several ways. One way is to take the air, cool it down, make liquid air, and the CO2 can easily be pulled out, and then you release the liquid air back into the air, and it evaporates, and you're better off that way. Here's the carbon carousel that we've been talking about. This was invented by a guy up in Canada, and basically this part revolves around, and each one of these screens is a separate sliding screen. So it revolves around, sucking air into it, and the chemicals in these screens absorb the CO2. When they get loaded, the screen drops down into this facility, which has a way of washing it out with warm water and cleaning the screen of the carbon dioxide that's in it. This can then be liquefied and do something with it. We don't know what yet. This is a brand new idea and is getting quite popular. He says that if we made 10 million of these carousels, we could purge 36 gigatons of carbon dioxide out of the Earth atmosphere every year. Now, what is that? Well, 10 million carousels is a lot, but we make 76 million cars a year. So it's not like an industrial challenge that we couldn't handle. And 36 gigatons of carbon per year, what is that? Well, that's more than we're putting in. In other words, even though China is putting up the coal-fired plants and so forth, we could suck more CO2 out of the air than China would put in. And it's worth about 5 parts per million per year. We're at 380 right now, and so we'd start to drop it down. That would be an excellent thing to do. It would be a major Manhattan Project kind of effort to put this together, but it's the one thing that shows us some hope in this situation. So what to do with the CO2? Well, first of all, you'd want to make it liquid. Why? Well, because it's compact and it's injectable much more easily, and you get a lot more CO2 in the volume, of course, with liquid. It's been suggested that we can sequester it in the deep ocean. This would be relatively easy. You run a pipeline down in the deep water. Deep water is very different from the surface water. It's slow, it moves cold, it's dark. So the carbon dioxide would come out as a liquid down there and bounce along the bottom, collect in pools in the deepest parts. That's not very popular among the oceanographers, though. They don't like to see their ocean tampered with, and they do point out that the ocean is acidifying from the atmosphere CO2 that's going into it. And this is changing the color of coral, and it's making species much less available and so forth. And so they say you have to deal with the ocean acidification that would happen. In other words, the deep ocean would get much more acid, and it would eventually show up in, say, 400 or 500 years. A better idea, they suggest, is sequestering it in deep rocks. Now, the geologists like this. They find that pressure of various gases is already being used to squeeze more oil out of oil wells. And so if they inject it deep down, say a mile down, what will happen to it? They think pretty well that it will stay down there for thousands of years. That's a very good thing. And it would give us time to figure out the next move. Well, we wouldn't know what to do with the extra CO2, but we could use it as a way of fending off ice ages, for instance, if we release some of it back once we had the global atmosphere under control. So what's the ethics of this kind of thing? Well, we're tampering with the planet. We don't fully understand it yet. That's the reality. Unfortunately, the problems that we're given from this rapid warming of the planet do not give us an infinite amount of time to think about a finely calibrated answer. Even though we don't understand the ecology of the planet well enough, we understand the heat budget of the planet pretty well. We know what would affect it. And so we'd have to say, even though it's complex, we are already running an experiment on the one lifeboat Earth, which we don't know what the consequences will be. So we're only a little worse off if we do something that slows or stops that heat accumulation, and we can figure out the details later. Species extinction is one thing that comes up very easily. Are we ready for that? Species will go extinct, and nature has been quite profligate in extinguishing different types of critters on the Earth. We're not the only ones that do that. So unfortunately, whatever happens, whether the planet goes ahead with its warming, whether we find a way to slow down and stop, species are going to go extinct, and we want to minimize that as much as possible. There are examples in the past. There's Scotch broom spreads around. There's the rabbits in Australia, which were not endemic to that area. They took over the place. So we have to be careful about what's going on with this. We don't, of course, it's a crowded planet. There's too many people. There's 6 billion people. And that's really the basic problem. So when you're fighting over diminishing resources, you have to make sure that you're not harming anybody as much as possible. We don't want this whole thing to degenerate into a world war, a big dogfight. And so we have to be careful about everyone's capabilities and what they need. The political and personal will required to do this has not been evident. Neither Obama nor even the Europeans, which are very much into this, much more than we are not really able to make much progress in reversing climate change. They are cutting down quite a bit on their use of fossil fuels, which is the best thing to do. But the Americans and the Chinese and others are not. So to summarize, each approach of this is limited. None of them completely solve the problem. It may be that we may need some combination of these things in the future. In normal times, such projects are really are not really able to make much progress in reversing. They are cutting down quite a bit on their use of fossil fuels, which is the best thing to do. But the Americans and the Chinese and others are not. Summarize, each are limited. None of them completely. It may be that it may be a combination of these things in the future. In normal times, such projects are really may need some are not really able to make much progress in reversing. They are cutting down quite a bit on their use of fossil fuels. Solve the problem. Fuels, which is the best thing to do. Approach of this is, but the Americans and the Chinese and others are not. Summarize, each are limited. None of them completely. It may be that it may be a combination of these things in the future. In normal times, such projects are really may need some are not really able to make much progress in reversing a bit on their use of fossil fuels. Solve the problem. Do. Approach of this is, but the Americans and the Chinese and others are not. Summarize, each are limited. None of them completely. It may be that it may be a combination of these things in the fuels, which is the best thing for the future. In normal times, such projects are really may need some. We like to think that that's a nice, handy space. Once we get the problems figured out on this planet, we can go up there and do it right. So that's the insights on earthly behavior from Dr. Wald for MCTV. Thanks for your attention. Earthly behavior.